Alright, here's our review for Investigation 4 as we have our midsummative exam coming up and some of the big ideas. How do rock layers get deposited in a basin? We looked at a basin in the front of the class where we said that eroded materials would start to pile up and they would get deposited in these areas as they get transported after being weathered. So the rock layers are going to, when they get deposited in a basin, always form flat horizontal layers that are separate and distinct. So you're going to be able to see where one layer stops, where the next layer starts, and they're always going to be flat and horizontal layers. One of the next things we looked at is the principle of uniformitarianism. With this principle of uniformitarianism, we look at processes that happen on Earth or in the universe, and because they happen the same way in the past and they're happening today and we can witness them, we can then start to predict or project that they will continue to happen that way in the future. So the idea of things being uniform or happening the same way all the time. And that's our idea of uniformitarianism. We also looked at the last thing where we kind of tie it all together, where we look at weathering and soil. So the soil is going to be created from broken down or weathered rocks and organic material. As the rocks start to break down, they're going to fall apart into sand, and if they get broken down and weathered farther, they're going to then become silt, which is smaller than sand. And finally, if they break down and weather even further still, then they would become clay, which is going to be a very, very tiny, small particle, the smallest of the three. And that would mix in with organic matter, leaf litter, dying plants, anything that would then give that surface a little bit of biology or kind of organic material life. As a quick review, going over some of the different worksheets that we went over in this section. We're looking at our Grand Canyon model, where the largest particles being deposited and the smallest particles being deposited. When we look at this, we want to think of the smallest particles traveling further, or the largest particles being deposited first, or not traveling quite as far. If we scroll down a little bit, we could see here with question 5, looking at the whole system of the Grand Canyon and what came first. We have our Colorado Plateau, our Colorado River, and our Grand Canyon. Well, we needed to have the plateau first, and then the river would spill over that, and that's why we kind of look at that spillover theory. As it starts to spill over that Colorado Plateau, it's going to start making waterfalls, and that river then is going to start to cut into the plateau and make the canyon. So we'd have to have the Colorado Plateau first, then the river, and finally that would create the canyon last. Okay, as we scroll down here, we had our weathering and erosion video, and we went over some of these topics. We also went over vocabulary and a PowerPoint on examples of weathering and erosion. Some of the things I want to point out here. Question 3, the most frequent cause of rocks to break apart is going to be frost wedging, or as water freezes and thaws and gets into cracks and freezes and makes those cracks bigger and then thaws and keeps this process going over and over and over. That's one that we should make sure we know for the test. You should also take a look at these last couple questions, 14, 15, and 16. With 14, we're looking at what size particles do we think the wind would carry farther, and what would be deposited first. So we see a very, very similar question when we look at the stream table and we talk about where the different particles ended up being deposited. Just like with the stream table, we're going to see that the smaller, lighter particles are going to be able to travel further, and the larger particles that are heavier are going to get deposited first or not travel quite as far. So it's the same thing whether it's the wind doing the eroding or moving of those particles, or if it's the water doing the moving or eroding of those particles. Okay, if we look at question 15, we're looking at the steps involved in breaking down mountain rocks and depositing that sand miles away. So we break it down into steps. The first thing that needs to happen is we need to break down those rocks, and that's going to be weathering. There's a number of ways that weathering can take place, by water breaking the rocks down, by frost wedging with ice. Plant roots can grow into them. Animals can break the rocks up by stepping on them. We could have a chemical breakdown with oxidation. or mild acids, breaking the rocks down into smaller pieces. Once those rocks get down into smaller pieces and they experience their physical or chemical weathering, okay, wind or water can carry those pieces from their original place. And once the wind or water then slows down, it's going to start depositing those particles in a new place. And as it deposits those particles in our basin again, when it gets deposited in that basin, they're going to be deposited in flat, horizontal, separate, distinct layers. And with our last question here, we're going to be looking at question 16. It's taken the Colorado River about 5 million years to erode away the Grand Canyon from a flat Colorado plateau. The Grand Canyon is about 4,500 feet deep at the south rim at Grand Canyon Village. If you were to visit Grand Canyon Village about 1 million years from now, what changes in the canyon would you expect to see? So if we keep moving into the future, we expect the canyon to get bigger. We expect it to get wider and deeper. More erosion and weathering would have taken place, and the sides of the Grand Canyon would probably be wider, and the river would be further down or deeper. In contrast to that, if we went back in time, we would expect the Grand Canyon to get smaller. It would be not as deep, not as wide, or shallower and narrower. So using that principle of uniformitarianism, we can kind of predict what the Grand Canyon would have looked like at just about any time in its formation, or at least an idea of what it would have looked like. If you have any other questions, feel free to stop by in class, and good luck on the test.